Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject electrical and electronics engineering. We're going to see the construction of SCR in this particular video. We will see what is SCR, what is the use of SCR, and we will see about basic operation modes of SCR, right? To start with, you ought to understand what is SCR first of all, right? So it is abbreviated as silicon controlled rectifier. Silicon controlled rectifier. It has a lot of applications. It can be used as switch. It can be used in regulators, in inverters, and almost in most of the circuits we use SCR, right? So this is called as silicon controlled rectifier, but actually it should be called as semiconductor controlled rectifier. Semiconductor controlled rectifier. When we say semiconductor, it can be silicon or germanium, but mostly silicon is preferred for SCR construction. That's because silicon has very low leakage current. That is why silicon is preferred mostly, and that is why it is also called a silicon controlled rectifier. But actually, it is semiconductor controlled rectifier, right? So now we will see the construction of SCR. When we say the construction of SCR, it is a four-layered device. It is called as four-layered device. Four-layered device. It has a P layer, N layer, and another P layer and N layer. So it is called as four-layered device. And when you have four layers, right, you will have three junctions, right? When you combine these two PN junctions, right, you will have one junction, and these two PN junction will form another junction, and these two PN junction will form another junction. So it will be three junctions will be there. Three junctions. Three junctions, right? And it has three terminals, right? The anode, it is the positive electrode which is in this particular P layer, right? The end of the end P layer, right? That is where anode is connected. The end N layer is where cathode is connected, whereas this is the negative electrode. And the gate is connected to the second P layer, which is nearer to the cathode, right? So it has three terminals. It has three terminals. So anode is the positive electrode which is connected to the end P layer, whereas cathode is connected to the end N layer, right? It is negative electrode, and gate is connected to the second P layer which is nearest to the cathode, right? So this is the construction of silicon controlled rectifier, where it has four layer. It is called as four-layer device, and it has three junctions J1, J2, and J3, and it has three terminals: anode, gate, and as well as cathode, right? And this is the symbol of SCR, right? Where this is known as anode, and this is cathode, and gate is represented like this, right? And this is the actual SCR, right? Where you can see this is cathode, this is anode, and this is gate, right? And before going to the working modes, you ought to understand the current direction. The current direction flow from anode to cathode. Anode to cathode, right? No current will flow from cathode to anode. So current will flow from anode to cathode. So the current direction is unidirection. Unidirection. But if you take SCR, right? How the current flow will happen in BJT? BJT it is called as bipolar junction transistors. That's because the current flows because of both majority and minority carriers. Whereas in FET, we saw what is JFET, right? It is unipolar device where only majority carriers will be involved in current flow. Whereas here you have two PN junctions, that is three PN junctions, which means you have two P layers and two N layers here, right? So the current flow is because of both majority and as well as minority carriers. Majority and the minority carriers. So we call it as bipolar device. We can call it as bipolar device. So already we have seen, so it is a 4-layer device, it is a 3-junction device, and also it has 3 terminals. The current direction is unidirection, and it is called as bipolar device because the current flows because of both majority and minority carriers, right? And this is the construction of silicon control rectifier, right? Whatever I said, that is what explained here. Anode is positively charged electrode, cathode is negatively charged electrode, where gate is connected to, gate is the one which controls the flow of current between anode to cathode, right? And anode is connected to the first p-type layer, and cathode is connected to the last n-type layer. Gate is connected to the second p-type layer above the cathode, right? And you got to understand here the outer layers p and n, right? The outer layers are heavily doped. This p and n layer is heavily doped, whereas the middle layers are lightly doped, right? And mostly silicon is preferred. The intrinsic semiconductor silicon is preferred because of very small leakage current compared to germanium, right? Coming to working modes, we will see the working modes in detail in next video, right? But here you got to understand, in working modes of silicon rectifier, there are 3 modes. One is forward blocking mode, forward conducting mode, and reverse blocking mode. Whereas in forward blocking mode and reverse blocking mode, the SCR will be in off state. Only in forward conducting mode, it is in on state, right? So what is this modes? We will see this in detail. But basically, you understand the operation of SCR can be considered in 2 different methods. One is with gate and without gate, right? That is whenever you give supply to gate or without gate terminal. So if you see here, this is one particular operation where, right, it can be used in forward blocking mode where you don't consider the gate, right? You're not giving any particular voltage here. That is, you are using gate as open circuit here. So gate is not considered here, right? This is one mode of operation. Another mode of operation, you will consider gate. That is, you will supply gate voltage to the gate terminal, right? And another important condition is to make the SCR to work, we have to forward bias the SCR, right? Forward bias in the sense, this anode has to be connected to positive and this negative, this N has to be connected to negative. So this is forward biased. So the current flows from the anode to cathode, right? We will see the working of this particular different modes in detail in next video, right? So today what we have seen is, we have seen the construction of SCR, why SCR is called as 4-layer device, right? Why it is called as bipolar device, why it is called as unidirection device, right? And it has 3 terminals, right? That is what we have seen in this particular video, right? And in next video, we will see the working of SCR. Thank you, my dear students.